In this lecture, I'm going to introduce the recommended tools which is officially given by the Rust community to write clean, efficient, and idiomatic Rust code. Now, these recommended tools you can use to improve your Rust programs so that you can format your Rust code very well. And if you have written any non-idiomatic code, then by using these tools, you can identify the code snippet where the code can be improved by writing in an idiomatic way and to format code according to the style and guidelines suggested by the Rust community. Now, one such tool is Rust Format. So this tool automatically formats Rust code according to the community style guidelines. It ensures that code across your project has consistent style, which is particularly helpful in collaborative environments. Another tool is Clippy. So Clippy is a linter. Basically, it's a static analysis tool used by Rust. But when you type the command cargo build, basically cargo build doesn't run this static analysis tool. So you can automate that. I mean, basically when you run cargo build, it uses its built-in static analysis rules or lint checks, what we call. For example, when you run a code which has unused variables or a function which is never called, you might have seen, like other programming languages, here also you will get unused variables or dead code warnings or unreachable code warnings. These are all some basic lint checks carried out by the compiler. But if you need some advanced level of static analysis of your Rust code, then you can use this tool called Clippy. So it analyzes Rust code without executing it to find wide range of issues that the Rust compiler itself doesn't necessarily catch. And we'll see some examples of it. Now let's see all these tools in action. So I'm going to take simple example. Here is a code what we wrote, very simple code. I said one thing, that this line, this code statement is too lengthy. That's why it is not well formatted code. Now you see the magic what happens when I run Rust FMT or Rust Format tool. By the way, these are the official repository where these tools are hosted. There is a good documentation. You can read about that later. And let me run Rust Format on this code. As you can see, the Rust Format tool has formatted a lengthy code statement in this way, and this we also discussed a while ago. Now let me do some more changes here. You see, whenever we use operators, like this is an assignment operator, or if you use any logical operators or arithmetic operators or comparison operators, so we always maintain a space around that operator. For example, here I have used assignment operator, like for example here. So I'll just remove these spaces, which is not a good coding practice. Now, as you can see, when I hit Rust Format, it automatically formats that. That's why whenever you are writing a long program, after some time, it is better to run Rust Format. Or before you check in your code, it's better to run Rust Format. And if you want to do this on Visual Code, then you have to install this Rust Format tool like this. First, you have to install it. Let me copy this. Let's go to the VS Code and let me just paste here. First, let's install that. It's already installed in my machine. Then you can just run cargo FMT, and you observe this line. This will be formatted, as you can see here. Now let's see this tool, Clippy, which is the static analysis tool. Now here, by the way, to install Clippy on your machine, you have to follow these steps. Basically, you have to execute this, and you have to run Clippy like this, cargo Clippy. Now let's see how Clippy can help us here in this code. So let's say I'll write entirely different code here. Let's say I'll take one simple example. Let's say let variable x is equal to, let's say 100. Then let me do let y is equal to x into 1, or x is equal to x into 1. As you can see here, this code has no effect, and I'm going to print ln. I'll just print the value of x. So now if I run this code, or if I do cargo build here or cargo run, as you can see, the cargo run or cargo build doesn't give any warnings because it's a legal code. It doesn't worry about this line of code which was actually redundant in this case. It has no effect. But if I run cargo Clippy on that, as you can see here, so Clippy has a problem with this code. Issues and warnings saying this operation has no effect. When you write non-idiomatic Rust code, then Clippy will warn you saying you can rewrite this code snippet in a more idiomatic way. For example, let me write one array. So don't worry about arrays, and also we'll explore these things later. Whenever you write comma in a Rust program, then we usually maintain one space after the comma character. Suppose, let's say you write this in a hurry, something like this. Don't worry about that. So you just run the Rust format tool and it will format the code. And I want to print the contents of the array by iterating over that array. For that, I'll use a very simple for loop. Let's say for I in 0 to, let's say 2, and I'll just print the value of the array, which is kind of a dangerous code here because I have to really think about using this range. Here I have to stop and think about this range. This is not an idiomatic Rust code, but it's a legal Rust code. So I goes from 0 to 2. Don't worry about this range expression and this for loop, and also I have not yet covered those things. This is just to understand Clippy, the behavior of Clippy. I run this code and Rust compiler doesn't have any problem with this code. It says 1 to 3. What if I make this as 3? As you can see, the compiler panics because I'm doing out of bound access here. I goes to 3, so where 3 doesn't exist here, which is not a correct way of writing the Rust code. Let me go back to this code here. Now here, this is a correct code, legal code, and the compiler doesn't issue any warnings, nothing. But look at Clippy. The Clippy is not happy with this code. Clippy says that it is not an idiomatic way of writing Rust code. So basically, it is asking me to iterate over an array immutably using the concept of iterator, which is a very helpful trait in Rust, and we are going to explore these traits and iteration and iterator methods little later. Don't worry at all for a time being. The goal of this discussion is just to say that, just to see that the Clippy actually forces you to shift from writing non-idiomatic Rust code to idiomatic Rust code. The Clippy forces you to adapt to writing idiomatic Rust code. Now let's see another example. Now in order to impress Clippy, I can rewrite something like this. For every item in array, something like this. I'll do something like this, and it is asking me to print the item directly like this. Basically, it is traversing over the array non-mutably, and we'll discuss more on this little later. And let's run Clippy on this, and Clippy is now happy with this code. Now let's see another example. Let's say I have pi value is equal to 3.14, and I would like to calculate the area of a circle. That area is equal to pi into, let's say, 4.0 into 4.0. And let's print the value of area. So the cargo build has no problem with this. It works, but Clippy has problem with this. As you can see, Clippy actually issues an error on this. That's because this lint check is on by default. There are many lint checks, so you can go to the documentation of Clippy. One among those lint checks is it is regarding using approximation of a constant. And this deny is on by default, so that's why you see an error here. Now, if you think that this shouldn't be happening, your program must allow constant approximation, then you have to override this lint check by copy pasting that lint check rule and make this as allow. Then it will override that lint check, and now Clippy has no problem with this code. But without this, if you want to fix this code in Clippy, then Clippy is giving some suggestions here. So basically it is asking you to import, use the constant defined in the standard library. So basically what it's saying is this constant, the phi value, is already there in the standard library and it is asking you to use that. I can just copy paste this here and I'll just use this as F64 or F32. Let's run this code. Alright, so I have to use std here, the standard crate. Don't worry about this thing. This is basically, we are pointing towards this constant by going through all these crates and modules. And we'll explore all these things as we make a progress in this course. Now let's run this, and Clippy is also happy with this code. Please note that using Clippy is not mandatory, but it is highly recommended as an additional tool to help you write more idiomatic and efficient Rust code. Now on the VS Code, we'll see how to use a Clippy tool by default. So you can always run cargo Clippy. But instead of running that command frequently, how do we activate Clippy while writing the code itself? For that, what you do is you just go to the settings of VS Code. For that, press Ctrl plus Shift plus P and then type open settings or open user settings JSON. Basically, it's a JSON file. And here you add this line. This is one of the settings of Rust Analyzer extension, what you had installed in the previous video. Then save this. And now, as you can see, when I type in some code and when I try to save this code, as you can see, the red squiggle appears on this code statement. And when I hover the mouse over that, it shows the diagnostic message. After that, there is one more tool which you can try it out, that is called Cargo Fix. This comes with a cargo installation, so you need not to install anything. This tool automatically applies fixes to Rust code based on the diagnostic messages or warnings provided by the Rust compiler, that is Rust-C. So this is particularly useful when upgrading your code to comply with newer versions or newer editions of Rust. We'll talk about Rust editions a little later. Basically, this command automatically apply fixes to your code based on the compiler warnings. And it is pretty much helpful upgrading to newer Rust editions. Like for example, if you want to migrate your 2015 edition based Rust project to, let's say, 2018 or 2021, etc. It can automatically update your code to comply with the new language syntaxes or idioms. But don't expect Rust Fix to fix all the warnings or ambiguous codes that you have written. It is pretty much selective if it is any ambiguity in the code, so it doesn't touch that code. For example, here I have a small code snippet. Here, as you can see, this function is not called from anywhere in the code. So basically, it's a dead code. When I try to compile this or build this project, as you can see, the Rust-C compiler issues warning saying there is a dead code, warning on dead code. So don't expect a cargo fix to fix this code by removing this function. The cargo fix won't do that. Let's say if I run cargo fix on this, and you have to send this argument hello dirty. So if you want to know all the options related to this command, just type --help. All the options you can explore later. So if I just run cargo fix hello dirty, and as you can see, it doesn't fix anything. Suppose if I, for example, call this function from here and supply the radius value, let's say 10.0. Don't worry about functions and argument sending and all these different syntaxes. Goal of this video is just to explore cargo fix command. Here, if you observe this code, first of all, here in the main code, area variable is unused, and here the variable radius is unused. Let's see whether cargo fixes that. When I run cargo fix hello dirty, and yes, as you can see, it actually fixed some warnings. First of all, it actually changed this variable to something like this. As you can see, the unused variables like radius and area here are prefixed with an underscore character. That underscore character has a specific meaning and purpose in Rust program. So we will understand more on that as we write more programs in this course. For example, here in this particular context of variables, that underscore character is used to indicate that a variable is intentionally unused. So that actually suppresses compiler warnings. Because when you declare a variable but you do not use it anywhere in your code, the Rust compiler usually triggers a lot of warnings about the unused variable. So by prefixing the variable name with an underscore, you signal the compiler that you are aware of that unused variable, and the compiler suppresses the warning.